So in last class we discussed about thermodynamics, right? And there we use one word, degree of freedom. I see in comment box many students were asking about what is degree of freedom. So actually this degree of freedom is in kinetic theory of gases. In that chapter this topic is there, and this topic particularly we will study when you will come here. That time we will discuss this topic. Okay, so don't go so much deep, we will discuss it later. Just remember, for monatomic gas degree of freedom is 3 and for diatomic 5. Okay, so today our topic is mode of heat transfer. Our topic is mode of heat transfer. Okay, mode of heat transfer. So if you remember, from last 4-5 days we were discussing only about heat. Agree or not? We discussed first calorimetry. If we supply heat, then how much temperature changes for a particular body, or phase will change, so how it will change, that we discussed. Then we discussed kinetic theory of gases, right? Ideal gas, gas laws. Okay, then we discussed thermodynamics. In thermodynamics also we discussed about heat, right? First law we discussed. First law is delta Q equal to delta U plus delta W. Delta Q is heat supplied, delta U change in internal energy, and delta W is work done. So there also heat. Again our topic is mode of heat transfer. So today we will discuss that how if we heat up anything. Okay, just an example. Suppose this is a iron rod. Okay, and we are hitting this iron rod from this end. We are hitting this iron rod from this end. Okay, only we are hitting here, only this part, not here. Okay, but after some time we see that this part also become hot. Agree or not? So this is a point that we have to think, what, that we are hitting from here. It should be hot, okay, but why it become hotter? What is the reason? Means heat is transferred from this end to this end, like this. Agree or not? So heat is transferred, right? So heat also transfer in a body. So what are the methods by which heat can transfer, that we will discuss today. So our topic is mode of heat transfer. So total 3 methods are there. Total 3 methods are there for heat transfer. One is, first method is conduction, second method convection, and third method is radiation. Okay, total 3 methods are there: conduction, convection, radiation. Okay, now understand 3 methods. So where a particular method is applicable, that we have to understand here. Okay, so first is conduction. To read the definition, the process in which the material takes an active part, by molecular action, and energy is passed, heat is passed from one particle to another, is called conduction. It is predominant in solids. Okay, so I given you example of iron rod. We are heating the iron rod. This part we are heating, but we feel after some time that this part also become hot. Okay, so if we are heating from this side, this part also become hotter, means heat is transferred like this. Okay, so how this heat is transferred? We give this mode name is conduction mode. How this heat transferred? We given this process name conduction. Okay, so what happen in this process? So when we heat up, then these all molecules will absorb the heat. You know, if they will absorb the heat, then their temperature will rise. Okay, If their temperature will rise, then what will happen? If temperature of molecule will rise, then what will happen? Send your response. Because earlier we discussed this point in kinetic theory of gases, we discussed this point. If molecule temperature rises, then what happen? Can you say what happen? Can you send your response? Kinetic energy increases. Yes, very good. So what will happen if we heat up? Then their temperature rises. If their temperature rises, then their speed increases. If their speed increases, so we can say that their kinetic energy increases. Okay. So if kinetic energy increases, then it affect what? To understand this point. Actually, what happen in a solid? Suppose if we talk about this marker, so it is solid. Okay, you can say yes. All molecules, here it is written max hub. Okay, so this letter M, it will remain here only. Now also, after 5 days also, its position is not changing. Agree or not? So solid means what? That molecule's position does not change. Okay, but in reality, what happen? In reality, all solid molecules, they vibrate like this. Now you can say, sir, if they vibrate, then this solid shape should change. No, actually, molecule size is very small. Molecule size is very small. We can't see a molecule. By our naked eye, we can't see molecule. Even by instruments also, microscope also, we can't see a molecule. Okay, that much small a molecule is. So just an example. If I say that I given you 100 rupees. Okay, so you will say, "Arey sir, 100 rupees, okay, we will do some party, samosa, like that we will eat." Okay. Now, if I will give 100 rupees to Ambani, then what Ambani will say? For Ambani, 100 rupees is nothing. Agree or not? He will throw that 100 rupees. Okay. 100 rupees is negligible for Ambani. Why? Because his capital is too much. Agree or not? Right? But for you, 100 rupees matter. I am not saying that it matter for you also so much, but it matter. You can go outside and you can eat something, right? Agree or not? So here also same way. For a molecule, its size is very small. So for this molecule, micrometer, you know micrometer 10 to the power minus 6, millimeter 10 to the power minus 3, millimeter, we can see millimeter on a scale, that smallest division, na, that is millimeter. Okay. So we can see millimeter, but we can't see micrometer. Okay. Again, less than micrometer is nanometer. Nanometer is 10 to the power 9, minus 9 meter. Nanometer is 10 to the power minus 9 meter. Okay. So actually what happen? These molecules, they vibrate. How they vibrate? Because between each molecules gap is there. That gap is how much? It is the order of 10 to the power minus 9 micrometer. Okay. So a small gap is there. We can't see that small gap. In that gap, these molecules vibrate like this. Okay. Now understand. So what is going on? That each solid molecule is vibrating like this. Each are vibrating. Okay. Okay. We are heating, then these molecule speed will increase. If their speed will increase, so they will collide. Agree or not? They will collide. And you know, if anything collide, then heat will, anything collide. Suppose just like this. So what will happen? If we do continuously clapping, then what will happen? Our hand will heat up and their temperature rises. So same thing here. So molecules will collide, so their temperature will rise. So this molecule temperature will rise. Now suppose we are hitting from this side, है ना? So what is going on? First this molecule energy will increase, okay, temperature will increase, its speed will increase, so it will collide with next molecule. Now next molecule, due to collision, its speed also increases, temperature also increases, so it will collide with next to next, okay, then next will collide with next molecule. So continuously it happen, and due to continuous collision their temperature increases, right or not? So heat transfer takes place in solids. This happen only in solids. By which mode? Conduction mode. Important point, that here molecules vibrate. Here heat transfer takes place due to the vibration of molecules. Is it clear to all? Okay, so heat transfer takes place due to vibration of molecules. So molecular action we can say. Okay. Now next mode is convection mode. What is convection mode? Now we discussed that in solids heat transfer takes place by conduction. Now in liquids heat transfer takes place by convection mode. How it takes place? Understand. We have a container. Okay. In container water is filled. Now we are heating the container. So what you observe? I think you all seen this process. What you observe, when we heat up the container, okay, in container water or any liquid is there. When we are heating it, at that time what happen? You will most of the students are saying boiling, okay, but what you observe there, vapor heat comes, bubble form on the wall of the container, water also get heated, bubbles are formed, changing of state, like that answer students are given. But I think only like that you are saying that bubbles form, okay. Have you observed this point, that when we heat up convection, understand this point, when we heat up this, suppose here water is filled, you all will say yes sir, yes, that we observe, but you are not telling it. This is suppose water, okay, now we are heating it, so what we observe? We observe here that these water molecule, they are in contact with the wall. First, which wall temperature will rise? This wall, okay. So these water molecule are in the contact with this wall, so they will heat up, their temperature will rise. So what we observe there, we see, you can do this experiment today only at your home. We see that such type of things, that here some molecules are there, water molecules. These molecules move up like this. These molecules move up. Like that we see. Okay. These molecules move up. Okay. Why they move up? That we have to understand. Okay. So actually what happen, when these molecules will come in contact with this wall temperature rises because we are heating it. Okay. So when these molecule will come in contact with the wall, these molecule temperature rises. If their temperature rises, so they will expand. Agree or not? Thermal expansion you studied. Okay. So these molecule will expand. Okay. So due to increase in temperature, of water molecule which comes in contact with container wall they expand. Now due to expansion what will happen? Due to expansion what will happen? Volume will increase. If volume will increase then density will decrease. Agree or not? They expand so volume increases and so volume increases and density decreases. Very important point. If density decreases then what will happen? If density decreases then what will happen? What will happen? If density decreases then these molecules become light. These molecules are heavy comparatively. Okay, here low density, here high density, right? Those molecules which are at the top, they are not in contact, so they are their density as it is, but here comparative density become less, so here low dense, here high dense, so low dense will move up, anything is light that will move up, okay, and high dense will move down. Agree or not? So at the same time if these molecule will move up, so these molecule will move down, these molecule will move down, these molecule will move down, right or not? These molecule will move down, right or not? Why? Because here comparatively these molecule density is higher than these molecule because they expanded, their volume increases, their density decreases. Agree or not? Okay, so density decreases, therefore these molecules become light comparatively top surface molecule. So due to gravity, mg, you know gravity, due to gravity top molecule will move down and bottom molecule will move up. Okay, now you can ask, Are sir, that okay, these molecules move down, these molecule will move up. Okay, that's okay, but it will repeat or not? It will repeat also. Why? Because now these molecules will come in contact, their temperature rises, they will expand, their density decreases, so they will move up, they will move down, so this process continuously happen. Okay, that's why uniformly water temperature increases. Is it clear? So, and this cycle repeat continuously until boiling. Boiling of liquid. Okay, so students, we understood convection mode. You can see all the lines. Okay, you can read each point, it is important. Is it clear to all? Now next, so next mode of heat transfer is radiation method. So here you have to remember that this convection mode takes place in liquid and gases. In fluids it takes place, and fluids means liquid and gases both. So you have to remember this point, that in liquid and gases convection, and the conduction takes place only in solids. Okay. Now radiation. First point, it is the fastest mode of heat transfer. It is the fastest mode of heat transfer. Okay. And one more point, actually in conduction and convection, solid, liquid, gases, medium are required, but here no requirement of medium. Okay. So here we can understand that in radiation, heat transfer without any medium. Convection, medium is required, right? And this heat transfer takes place due to density difference. We discuss due to density difference, right? Lower molecules, low density, upper molecules, high density. So heat transfer due to density difference, very important point. Okay. And here heat transfer takes place due to temperature difference, but how it happen? Due to vibration of molecules. Okay, due to vibration of molecules. Here we can see due to vibration of molecule. Okay, here completely displacement. One molecule which is at the down, it displace from one point to another point. So here displacement of molecule. Here displacement of molecules. Here no displacement, only vibration. So here only vibration, here displacement, and here it takes place due to the electromagnetic wave. Now it is new word for you. You don't know about electromagnetic wave. It is new for you, so we will discuss it later. So here it is due to electromagnetic wave. Okay, we discussed that this happen in liquid and gases, and it happen only in solids, and here no requirement of medium. Okay, it takes place in vacuum also. And you can ask, sir, can this radiation mode takes place in medium? Yes, in medium also it takes place, but at the same time, if you ask that in vacuum it takes place, yes, no requirement of medium. So medium and no requirement of medium means medium and vacuum, at both this radiation takes place. Is it clear? Okay, so no medium required, and it does not mean that it only takes place in vacuum. It does not mean. In vacuum and in medium, one example understand. Suppose I given one day example of tea, right? Hot tea cup you have, you put in the surrounding. Okay, what happened? That hot tea cup becomes cool after some time. Agree or not? Okay, so what happened there? Heat is transferred from tea cup to the surrounding. Agree or not? So this heat is transferred from one body to another body. So this method is here radiation. In convection, we are heating the liquid. The heat is transferred from liquid molecule to liquid molecule only. In conduction, we are heating this iron rod. So heat is transferred inside the solid only, from one point to another point. Right or not? So conduction inside the solid only. Okay. Convection inside the liquid or inside the gases only. Okay. Now radiation change is there. Tea cup to surrounding. Right or not? We put this hot iron rod in the atmosphere. It will also become cool. So heat transferred from this hot iron rod to the surrounding. So this is also what? This is also radiation mode. Is it clear? Understood? Okay. So if there is a change in medium, one body to another body, then we talk about radiation. Only solid, inside the solid only heat transfer, then conduction. Inside the liquid only heat transfer, then convection. And from one body to another body, whether it is solid, liquid or whatever, then radiation. Generally another is surrounding. Clear? Okay. So here we understood. Now I given you the example of radiation mode also. Okay. Now this radiation mode is fastest mode of heat transfer. It is fastest mode of heat transfer. Okay. Why? Because here heat transfer takes place by the speed of the light. Okay, and you know speed of light is 3 into 10 to the power 8. Okay, here it is slow process and this is also slow process. Is it clear? So we understood all three mode of heat transfer and in detail we understood convection mode. Now we will discuss conduction mode in detail. Okay, so conduction mode. Already some points we discussed that this conduction mode, due to conduction mode, heat transfer takes place in solids. So what example I given here, that this is any metallic rod, iron rod you can say, aluminium, copper, whatever. We are heating it. Okay, if we are heating it, what will happen? These all molecule temperature will rise. Here molecules are there, their temperature rise, so they will vibrate. So they will collide with next molecule. Next molecule heat, if they will collide with next molecule, then next molecule temperature increases, so speed also increases, speed increases, then this molecule will collide with next, and it happen continuously. Due to that, here also temperature, this end temperature increases. Okay, right? So always remember this point, that this end temperature is less, this end temperature is higher. Heat is transferred here due to temperature difference. If no temperature difference, then heat can't flow. Is it clear? Okay. So here reason, cause of heat transfer is temperature difference. So heat transfer takes place due to temperature difference. Okay. Now how much heat transfer takes place? We can measure heat, you know heat unit is joule. Okay, so how much heat transfer takes place? So a formula is there, we have to remember this formula. So what is it? Understand. Suppose that this end temperature is T1 and this end temperature is T2. Heat transfer takes place from higher temperature to lower temperature. From higher temperature to lower temperature. Okay, so here T1 is greater than T2. T1 is greater than T2. So heat will transfer from this side to this side. Okay, now this is a rod and this rod cross section area, here this is what? Cross section area. This area is A. And this rod length is L, this length is L. Okay, is it clear? Now understand, suppose how much heat is transferred? Delta Q. This is what? Heat transferred in time delta t. Okay, how much heat? Delta Q. How much time? Delta t. Okay. A is cross section area. Okay. So actually here this delta Q heat transfer takes place in how much time? Delta t. So this is what rate of heat transfer. This is what rate. If you compare any quantity with respect to time, then it become rate. So rate of heat transfer. Okay. So this rate of heat transfer is proportional to temperature difference. You agree or not? If high temperature difference, then heat will transfer more in a less time. Agree or not? Okay. At same time, this heat transfer is proportional to this area. If area is more, so more heat will transfer, because heat is transferring like this. So this area is required, na? Heat is transferring, heat is crossing this area. If this area is more, then heat transfer also more. So it is proportional to A. Okay. And heat is transferred from this point to this point. If this point is far away, then it take more time. If this point is near, then it take less time. Means length is more, then it will take more time. If length is less, it will take less time. Right? Right or not? So this heat transfer rate is inversely proportional to length. Length more, more time. Length less, less time. Agree or not? If we combined all three, then it become delta Q by delta T is proportional to A into temperature difference and length divide. Now already we discussed this point that when we remove this proportional sign, then we have to multiply with a constant. So here also same thing we have to do. Here also we have to multiply with a constant. And here this constant is, K. Okay. So what is K here? K is constant and we call it thermal conductivity. What we call this constant? Thermal conductivity of the metallic rod. Is it clear? So what is K here? Constant. Okay. So we understood this point. What? That heat transfer, rate of heat transfer is equal to, formula is Ka T1 minus T2 by L. What is T1? Higher temperature. T2 lower temperature. L distance between one end to another end. Okay. And length, length we discuss. Area of cross section is A. Area of cross section I explained. Heat is crossing this area. Heat is crossing this area. Okay. This road, this road has two area. Suppose road is similar like cylinder. Okay. So this cylinder has two area. One is this area. This area. Curved surface area. And one is this area. Circular surface area. So if we are hitting this end, so heat is flowing like this. So heat is crossing which area? Circular surface area. This area. So we have to take circular surface area. Agree or not? Okay, this area. What is K? Thermal conductivity of the metallic rod. Okay, it is a constant here and we defined this constant as a coefficient of thermal conductivity. Clear? About this case, some information. It depends on the nature of the metal. It depends on the nature of the metal. How? We are heating aluminium, we are heating copper, right? Maybe this is a possibility that aluminium temperature rises more than copper. Agree or not? So whose temperature will rise more? Who will decide? K will decide. So their K is different, that's why it happened. Is it clear? Okay friends. Now we understood it. This conduction mode we understood. Okay, convection mode I explained you. This is convection mode. About radiation little bit we know, we discussed there, and further we will discuss in next class. Okay friends, thank you for listening me, and I hope you understood about convection and this conduction mode formula also we discuss, and further we will discuss in next class. Thank you.
Good morning everyone. My name is Ravi Kiran. I teach chemistry for the next few days. Presently today topic is types of redox reactions. I think you already in the previous classes you are familiar with the calculation of oxidation states of elements in a compounds. Now that will be helping us now today to find whether a reaction is first of all redox reaction or not. If it is a redox reaction, what type it comes under. There are different types of redox reactions are there, which we will study today. Before beginning the types of redox reactions, let's see first how to find whether a reaction is redox or not. See, redox reaction. Redox reaction means reduction plus oxidation. When these two taking place, this reaction is called, such reactions are called redox reactions. Now, next question comes up, what is reduction, what is oxidation? See, oxidation, in terms of electrons, the definition is like this, reduction and oxidation. Reduction means gain of electrons. When something electrons are gaining, if a species is gaining the electrons, then it is called reduction. Oxidation, it is the reverse. That means losing electrons. Loss of electrons is reduction. Sorry, oxidation. Now, if both gain of electrons and loss of electrons both are taking place in a reaction, such reaction is called redox reaction. And there is one more other way, easy way to find whether a reduction is taking place or oxidation. This is the main definition, keep this in mind. But one more other definition also I am telling you. That is, reduction can be also defined as decrease in oxidation state. You know already how to find oxidation state. Now, if oxidation state is decreasing, then it is called a reduction, decrease, reduction. When oxidation state is increasing, that is called oxidation. This is another easy way, actually when a chemical reaction is given, the more easier method for us to identify is the second one. Find oxidation states and see whether it is increasing in a reaction or decreasing. We will see some examples, but this is the basic definitions. Okay. Now, let's take one example, one reaction, and figure out what is undergoing reduction, what is undergoing oxidation. Okay. And first of all, we need to figure out whether it is a redox reaction or not. Okay. Let's take the example. Now see, suppose calcium carbonate, limestone. Calcium carbonate on heating, it will decompose into CaO and CO2. Now let's find out whether it is a redox reaction or not. That means if oxidation states are changing, then yes, it is a redox reaction. If they are not changing, then it is a non-redox reaction. Now, you know already in the previous classes, I'll just remind you, when group 1 elements are there, what are the group 1 elements? Lithium, sodium, potassium, mostly we will come across this, rubidium, cesium also, group 1 only, but mostly in compounds we will see lithium, sodium, potassium, group 1. Now, group 1 elements always have +1 oxidation state in their compounds. So, it has +1 oxidation state in their compounds. It will help us in calculating oxidation states. I am reminding you few points. And group 2 elements. What are the main group 2 elements we will come across? Beryllium, magnesium, calcium, strontium, barium. These elements in their compounds, they exhibit +2 oxidation state. And aluminium +3 state. And hydrogen. Hydrogen can exhibit 2 states, +1, -1. When it exhibit +1 state, when it exhibit -1 state. See, it exhibit +1 state with non-metals. Suppose hydrogen is in a compound, hydrogen is combined with a non-metal. It is existing along with the non-metal. Then it will have a +1 state. For example, H2O. Oxygen is non-metal, so hydrogen there oxidation state is +1. HCl, chlorine is a non-metal, so hydrogen has +1, like that. Suppose hydrogen is in combination with metal, then it will have a -1 state. For example, sodium hydride, NaH. In NaH, Na is a metal, so H will have -1 oxidation state, not +1, like that. And oxygen. Oxygen usually -2 will come across in -2 normal oxides. Most of the compounds we see normal oxides only, and you take it as -2. But rare cases you will see where oxidation state is -1. Those are called peroxides. When a compound is given, if you don't know whether it is a peroxide or not, assume it is normal oxide, 99% it will be correct, and take -2 and proceed. In the syllabus, when you are reading the different chapters, you will come to know important peroxides in different levels. Then it will help in the final exam. But as of now, when oxide is given, assume it is normal oxide, so take -2 and proceed in problems. That's it. These are some important points you need to memorize to calculate the oxidation states. And one more important point is, sum of all oxidation states in a species, all the elements, sum of all must be equal to its charge. That charge, if it is 0, then equate it to 0. If it is an ion, cation or anion, whatever charge is there for that species, equate to that. Now here CaCO3 is there. First, let's see oxidation states of species. Now calcium is a group 2 element. Group 2 element calcium. So in compounds, what is its oxidation state? Its oxidation state is +2. Calciums. Here carbonate, CO3 -2 is there. Now, CO3 -2, calcium +2, then carbonate is CO3 -2. So, in carbonate, oxygen is there. So, oxygen oxidation state, what we will take? -2. As an oxide, its oxidation state -2. Carbon, what is the oxidation state of carbon? We need to find out. Now, let's take it as X. Sum of all oxidation states must be equal to the charge of the species. Charge is how much? -2. So, add them then. X plus 3 oxygens are there. 3 into -2 -6 for the total oxygens is equal to charge. What is the charge of carbonate? -2. So, from this you will get 4. 6 -2, 4. So, carbon oxidation state is 4. Oxygen is -2. We already know. Okay, now come to the right side. Let's see if oxidation states here are same or different we are getting. If they are different, then we can understand a reduction oxidation things are happening here. Okay. Again, calcium is there. Calcium means group 2 element. In compounds, always +2. Oxygen -2. Oxygen -2. If oxygen is -2, what will be the carbon? Let's take X here again and find out. X plus 2 oxygens. 2 into -2, -4. And CO2 is not a cation or anion. It is a neutral molecule. So its charge will be 0. So X is equal +4. So +4 we are getting here. Carbon is going from +4 to +4 only. Oxygen -2 to -2 only. Calcium +2 to +2 only. There is no change in oxidation state. Therefore, this is not a redox reaction. Okay. Now let's take another example, which is a redox reaction, and see. KClO3 gives KCl plus O2. Now, in this potassium is which group element? First group. In the beginning we have written. First group means what? +1 state. So, potassium will have +1. Chlorine, we don't know. And oxygen, yes, oxygens I told you to take -2 usually. So, -2. Let's take chlorine is X. Let's figure out that chlorine. Sum of all will be equal to its charge. It is a neutral molecule, charge 0. So, what is the total sum then? 1 potassium, 1 into +1 +1. 1 chlorine, 1 into X, X. 3 oxygens, 3 into -2, -6. Overall charge is 0. So, what is the X you are getting? +5. X you are getting -6 plus 1 is -5. When you take that side, +5. So, chlorine oxidation state is +5. Now, again, come to the right side. Potassium, first group element +1. If it is +1, overall should be equal to its charge, which is 0. KCl is a neutral. So, KCl charge is 0. So, if it is +1, chlorine has to be -1 only. Then only addition of these two will be 0. Now, O2. See, if any element is combined with the same element, O2, H2, N2, if element is combined with the same element, bonding with the same element, then oxidation state will be 0. Okay, this also you must have learned in the previous classes. So, in compounds only non-zero oxidation states will be there. In elements, always oxidation state 0. So, 0. Now, see, potassium is going from +1 to +1 only, no change for potassium. Whereas chlorine, what is the X we got? +5. X we got +5. +5 state, it is going to what? -1 state. Which one? Chlorine. +5 to -1. Oxygen is going from where? -2 state to 0. So, oxygen -2 to 0. -2 to 0 means what? Oxygen state is decreasing or increasing? -2, 0. 0 is bigger number, -2 is smaller number. So, -2 to 0 is increasing, whereas +5 to -1 is decreasing. See, +5 to -1 is decrease in oxidation state, whereas -2 to 0 is increase in oxidation state. Decrease and increase. And decrease in oxidation state is reduction, increase in oxidation state is oxidation. So, it is a redox reaction. This is how you have to find. Actually, you will come across questions like which of the following is a redox reaction. Such kind of questions are asked in NEET exam. Which of the following is a redox reaction? They will give 4 reactions. In each option, one reaction they will give. So, you have to see the oxidation state. Wherever oxidation state is changing, then you can identify that is a redox reaction. So through practice, you have to be fast in calculating oxidation states. For each option, if you are taking so much time, then one question only you are consuming a lot of time in exam. So by practicing such questions more and more, then you can get grip over it. You will calculate faster. Okay, now let's see types of various redox reactions. Now, first one, combination reactions. As the name itself is saying, combination means what? There are two things combining. Okay, they are combining and form a single product, single molecule. That is what combination. For example, C plus O2 gives CO2. This combination only. Two species are combining to form a single entity. So this is a combination. Like this, reactions come under combination reactions. Second, decomposition reaction. For example, if you take H2O gives H2 plus O2. For balancing purpose, I have taken these numbers 2 here and 2. But actually what is happening? Water molecule is breaking. Breaking is also called decomposing. Decomposing into what and what? H2 and O2. So when a species is breaking into parts, individual molecules, it is called a decomposition. It is a reverse of the combination reaction. Okay. Now remember, suppose if I take CaCO3 gives CaO plus CO2. Here also a single entity is breaking into different species here. So this is also a decomposition. But we are discussing what? Types of redox reactions. Redox reactions, in that category only we have to see the different types. This is a decomposition, but we should not discuss this as an example here, because all examples should belong to a redox reaction here. But CaCO3 in the beginning only we have seen the decomposition is a non-redox reaction. Oxidation states are not changing. Therefore, this is a decomposition definitely, but this will not be a redox reaction type here. Okay. Next, the third type of reaction, metal displacement. Metal displacement reaction, meaning displacing. Displacing means what? Replacing. Metal is replaced or displaced by something. That is called a metal displacement reaction. Now, suppose if I take zinc plus CuSO4 gives a reaction like this. Now here, if you see, the zinc is displacing. See here, zinc comes and kicks this copper out of the molecule. When it kicks this copper out of the molecule, then in its place, what is coming now? Zinc is coming. So zinc, when it comes in the place of copper, by removing this in its place, then formula will be what? When zinc comes here, ZnSO4 and copper is out of this. So here this metal is displaced or replaced by the other metal. Such reactions are called metal displacement reactions. Next, non-metal displacement reaction. This is also displacement. But now which is getting displaced or replaced? Non-metal, not the metal. Okay. Now see, suppose Na plus H2O gives NaOH plus half H2. Now see, in this reaction, this is a metal, fine. But if you look at this is what this is doing. See, H2O, can I write? H2O is written as H and OH. HOH, which is H2O. Now, in this position of hydrogen, if sodium comes and occupy in its place, then the formula will become what? In its place, if sodium comes, NaOH. And this is how sodium is coming in the place of hydrogen to form NaOH. So, which is getting displaced or replaced? Hydrogen is getting replaced. By whom it is getting replaced, that is a different thing. But it is getting replaced here. So, it is called a non-metal. Hydrogen is a non-metal displacement reaction. And similarly, suppose if you take Na plus HCl gives NaCl plus hydrogen. This is also which is getting displaced? Non-metal. This is also non-metal displacement reaction. I hope you are clear up to this. Next, fifth redox reaction is very important. Quite often you see this in exams. Disproportionation. Disproportionation reaction. Now, here, what is a disproportionation reaction? Listen carefully. The same element, of course, it is a redox reactions only we are discussing. So, reduction oxidation takes place. But same element, if it is involved in reduction, as well as the same element only involved in oxidation, then it is called a disproportionation. What is disproportionation? Same element involves in oxidation as well as reduction. Same element, then that is disproportionation. Let's see. Suppose let's take a reaction like this. Now here, let's write the oxidation states and see disproportionation or not. Hydrogen combined with oxygen. When hydrogen is combined with non-metal, it will have what oxidation state? +1. So, hydrogen +1. Now, here keep one thing in mind. This molecule is called H2. H2O is water. H2O2 is called hydrogen peroxide. The name itself is hydrogen peroxide. And peroxy oxygens, already mentioned, oxidation state you should take it as -1. Okay, so here it is a peroxide and oxygen oxidation state is -1 here. Normal water, H2O means water only, and water has hydrogen +1, oxygen. Normally what we will take, that only you take -2. Here don't look at this 1/2. For finding oxidation states, this 1/2, 1/3 does not have any meaning for us. Look at the only molecule. What is the actual molecule here? O2. Look at that only. Forget about other numbers there before in front. Now O2 is a compound or element? Element. Compound means if an atom joins with different atoms, it is called a compound. Here oxygen atom is joined with another oxygen atom only. Such things are called elementary states or elements. So O2 is an element. For element, oxidation state I already mentioned previously, 0. Okay. Now, if you see, oxygen is going from -1 state to -2 here. Same -1 state, 0. So -1 to -2. -1 to -2 is what? Increasing number or decreasing? Actually 1 to 2 is increasing only, but minus sign is there. So opposite. So -1 to -2 is a decreasing. So this is a decrease in oxidation state. OS I will write. You understand, OS means oxidation state. Decrease in OS. Oxidation state of oxygen decreasing. Now what about other parts? The -1 to 0. -1 to 0 is increasing or decreasing? -1 to 0 is increasing. So this is oxidation state increases for oxygen. So if you see clearly, oxygen is involved in reduction. Decrease in oxidation state means reduction. It is involved in reduction, as well as same oxygen element is involved in oxidation. When same element is involved in oxidation as well as reduction, that is called what? Disproportionation. So this is a disproportionation reaction. Let's take another example. KClO3. You have seen earlier this example, KClO3. KClO3 gives KCl plus O2. I am not balancing the reaction. Balancing is not required for deciding a reaction is disproportionation or not. That numbers we don't bother. So if you look at this, potassium, already we have done this previously. I am directly writing oxidation states. Okay. Now if I ask, is this reaction disproportionation or not? See, potassium, no change. Chlorine +5 to -1, change is happening. Oxygen -2 to 0, change is happening. Change is happening means redox reaction. But should we call it as a disproportionation? No, because same element should undergo involve in oxidation as well as reduction. But here what is happening? Chlorine is involved in reduction, oxygen is involved in oxidation. So this is not a disproportionation reaction. These are the different types of reactions. So today whatever we have discussed, first let me revise that. Initially we have discussed what is a redox reaction. Redox reaction means what? Oxidation as well as reduction. Both should happen in a reaction. What is oxidation? What is reduction? The basic definition of oxidation is losing of electrons. Reduction means gaining of electrons. But most often in questions, the helpful definition is increase in oxidation state is oxidation, decrease in oxidation state is reduction. Now afterwards we have discussed types of redox reactions. Combination is very simple, two things combined form product. Decomposition is one thing breaks down into multiple products, decomposition. Third one, metal displacement. A metal is displaced by the other metal, that is metal displacement. If a non-metal is displaced by the metal, it is a non-metal displacement reaction. Finally, disproportionation means same element should undergo oxidation as well as it undergoes reduction. Let's see a few problems on whatever we have discussed. And one more thing, before going into the problems, I will tell one more terminology, reducing agent and oxidizing agent. Say, suppose Mg plus O2 gives MgO. Okay, now in this, first let's see which is undergoing reduction, which is undergoing oxidation. Then I will tell the terminologies. Magnesium, when you take only magnesium, it is the element. It is not combined with other atoms, other elements, it is not combined. So in elementary state, oxidation state is always 0. Oxygen, here also element only, because oxygen atom combined with another oxygen atom only, so it is element only. So oxidation state is 0. Forget about this number, it is for balancing purpose, it is there. What is the actual compound? Focus on that only, MgO. Now it is a compound. Now see what is the oxidation state. Now magnesium is a group 2 element. Group 2 element in their compounds always oxidation state will be +2. So magnesium will have +2 oxidation state. Oxygen, oxides, normally we take oxides, and as oxides it has -2. Okay, now magnesium is undergoing what? Magnesium is undergoing 0 to +2. 0 to +2 means what? Increase in oxidation state. Increase in oxidation state means oxidation or reduction? Oxidation. So oxidation is happening. To whom oxidation is happening? Magnesium reactant. Okay. What about reduction? Which is undergoing reduction? See, oxygen is undergoing 0 to -2. 0 to -2 means oxidation state is decreasing. Decreasing oxidation state means it is called reduction. Oxygen is undergoing reduction. Okay. Now, the one which is undergoing oxidation, that helps in reducing the other one. Which is undergoing oxidation? Magnesium is undergoing oxidation. In the process, it is helping the other one to undergo reduction. So, if a species is helping the other one to undergo reduction, that is called the reducing agent. Reducing agent. Sometimes actually students wrongly think this concept. They think that if a species is undergoing reduction, it is called reducing agent. No, if it helps in reducing the other one, then it is called reducing agent. For example, if I take LIC agent, okay, LIC agent means what? This helps other people to make the policies, LIC policies. It is not he takes the LIC policy, that's why LIC agent. No, right? So when we add the agent term, because if he is helping the other one in that respect, we call it so and so agent. For example, detective agent. He is helping in detecting the other things, or on his own for himself he is detecting something. No, he is helping the other persons. He is helping the other customers in their detection process. So always agent is there means, remember, helping the other person in that respect. That's why that agent we are giving the name. Reducing agent means helps in reducing the other one. Reducing the other one. Oxidizing agent means helps in oxidizing the other one. That's why it is called oxidizing agent. So this is the basic definitions. As a shortcut, you can remember like this. If something is helping the other one to reduce, this should undergo what? Oxidation. This should undergo oxidation. So reducing agent will involve in oxidation process. Oxidizing agent means helping other one to oxidize, means it will involves in what? Reduction process. So oxidizing agent means we have to see which is undergoing reduction. Reducing agent means we have to see which is undergoing oxidation. This is a short way to identify. So magnesium is undergoing what? Magnesium undergoing what? Oxidation. So should we call it oxidizing agent or reducing agent? Undergoing oxidation means reducing agent. And what is undergoing reduction? O2 is undergoing reduction. O2 is undergoing reduction means we should call it as oxidizing agent. These are the terminologies. Okay, I'll stop here. Tomorrow on the same concepts, first we will see some problems, okay, on how to attempt whatever we have learned. Practice is required. So various reactions we will see, write oxidation states and figure out whether it is disproportionation reaction, whether it is a redox or not. okay, which is reducing agent, oxidizing agent. All these things tomorrow we will see in the problems. Thank you. Thank you for listening.
Hello students, good morning. How are you? In this online program, this is the last phase. I think it is around 5-day program. Last botany topic, plant kingdom. In NEET point of view, more weightage is topic. In last year means 24 NEET examination, 4 questions are given from this chapter, plant kingdom. In terms of the textbook matter, very less matter, but information is the more. In terms of the number of pages or content, very lesser. Few number of pages, just 5 to 6 pages are there in NCERT textbook. But more weightages, we can make many more 2 to 3,000 questions within this 5 to 6 pages content. More conceptual, a slightly boring or difficult also. But be ready to catch each and every point. Today our topic is plant kingdom. Already you learn about the classification of all the biological organisms in this universe. Under the heading of the chapter, biological classification. Madam explained very detailedly about the 5 kingdoms of the biological classification or living world. According to the scientist Whitaker, all the living things, nothing but living world divided into how many kingdoms? 5 kingdoms. 2 kingdom classification is there, 3 is also there, 4 is also there, 5, 6, 8 kingdom classification is also there. Recent classification is 8 kingdom classification. 6th kingdom classification and 8th kingdom classification not mentioned our syllabus. Widely accepted, majority of the biologists accepted this 5 kingdom classification. According to that, 5 kingdoms are there. One is the Monera. It is allotted for all prokaryotes. Protista. It is a special kingdom allotted for all unicellular eukaryotes. Fungi or fungi, one unique kingdom. Well-known kingdoms Animalia and Plantae. Plantae. Now this week syllabus is about the plant kingdom. Here some important basics. How can you differentiate the Plantae from remaining 4 kingdoms? How can you differentiate the members of the kingdom Plantae from other 4 kingdoms Animalia, Fungi, Protista and Monera? All the members of the Plantae are mostly eukaryotes. Mostly multicellular eukaryotes. Monera, only unicellular. Unicellular. Fungi, except yeast, remaining all are multicellular. Animalia, multicellular. So Plantae easily differentiated out from the Monera, Protista. But some similar features are there between the members of Fungi, Animalia and Plantae, such are multicellular organisms. Multicellular organisms. It is one of the similarity between these 3 kingdoms. How can you differentiate the fungi from Animalia? Cell wall present in fungi, absent in Animalia. That is a clear differentiable feature. But whereas in plant, cell wall is there. Both fungi and Plantae, common feature is presence of cell wall. But cell wall mainly different. The cellulose plus pectin is there, the mainly cellulosic cell walls are found in Plantae. The most very important difference between members of the Plantae to other remaining kingdoms, presence of the one cell organelle chloroplast. Due to presence of chloroplast cell organelles, members of the Plantae are completely independent, photosynthetic and dominant. Food producers, independents, photosynthetical, autotrophs, fungi, heterotroph, Animalia, heterotroph. But all the members of the Plantae are autotrophs, nothing but photosynthetic and multicellular and eukaryotic organisms. This Plantae furtherly divided into how many groups? One is algae, second bryophyta, third pteridophyta, fourth and fifth gymno and angio respectively. These are the 5 groups of plant kingdom: algae, bryophyta, pteridophyta, gymnosperms. Algae is the primitive plants or lower group, remaining all are higher groups. Among these four, Brio, Teodo, Gymno, Angio, highly evolved plants in this plant kingdom are as present in this planet angiosperms. Angiosperms are the highly evolved group in entire plant kingdom. Highly reduced ones, simplest primitive plants in the plant kingdom, algae. Highly advanced and developed plants in the plant kingdom, angiosperms. Identify the structural variation between these five groups. These are algal members, purely aquatic, grown in water. Moist localities, bryophytes, pteridophytes, gymnosperms, but flowering plants are angiosperms. There is no flowers in first four groups, but flowering and seed and fruit yielding plants are angiosperms. Algae, Brio, Ptero, Gymno, angiosperms. Introduction part. Heterotrophic organisms like fungi. All fungi are heterotrophs. Majority of the prokaryotes, Monera, and unicellular eukaryotes, that is the protista, possessing cell walls. One question ready here. Commonly frequently asked question. Cell wall is found in. Question ready ra. Try to give answer for this question. Cell walls are found in. Try to give answer. Cell wall is present in all the members of the fungi. First option. Second option, majority of the prokaryotes. Third option, protista, some of the protista. Fourth option, all of the above. All of the above. Question is, cell wall is found in. As per given examples, you have to choose prominent answer for this question is the fourth option. PLANTAE not mentioned here. There is no doubt. Plant cells possess cell wall. But the PLANTAE option is not given. Okay, fungi, most of the prokaryotes, nothing but a Monera, and unicellular eukaryotes like protista, cell wall is present. So right answer is the fourth option. Next point. Now they have been excluded from PLANTAE, except these all organisms and Animalia, remaining all are placed under PLANTAE. Now they have been excluded from PLANTAE, though were in earlier classifications. According to the two kingdom classification announced by the lineage scientist, fungi, prokaryotes, Monera, protista, all are placed under PLANTAE due to the presence of cell wall. But according to the latest classification, all these organisms are removed out because all these are heterotrophic organisms. Lack of autotrophic nature in all these members, these are excluded out from PLANTAE. So the cyanobacteria that are also referred as the blue-green algae. Another name of cyanobacteria, BGA, full form blue-green algae, are placed under PLANTAE once upon a time, not now. Once upon a time, cyanobacteria are the members of the PLANTAE. After creation of one kingdom, Monera, these cyanobacteria placed under Monera and removed from PLANTAE. They are not algae anymore according to latest classification or recent advancements. Once upon a time, algae is the one of the group in that blue-green algae are placed. At present day, all the blue-green algae are removed out from algae and PLANTAE and placed under a separate unique kingdom for the prokaryote, that is the Monera. Next point, these are the algal members. What kind of plant body is found in algal members? In this plant body, there is no root. Root absent. In algae, stem is present or absent? Try to give answer for my question. Is stem present or absent in algae? Algae, the primitive plants in the plant kingdom. Root absent. But what about the stem? Yes, absent. Leaves. Leaves are generally photosynthetic organisms. There is also absent. No root, no stem, no leaf. But how can you say it is a plant? Because only one reason, that is the autotrophic nature, or due to the photosynthetic structures, presence of chloroplast, it is called PLANTAE. The plant body which is not differentiable into root, stem, leaf, such kind of plant bodies are called thallus. It is a very, very important point. Once give the definition for the thallus. Thallus is a kind of plant body not differentiable into root, stem, leaf. You might have seen thallus-like organisms. As organisms with the body thallus-like. In stored water or stagnant water, a green color mass is freely flowed on surface of the body, surface of the water localities, or bottom of the water localities also. A greenish mat is found. The green color mat is the thallus-like structure. Once give the definition for thallus-like structure. Thallus, it is a plant body not differentiable into root, stem, and leaves. Presence of thallus is the characteristic feature of all the algal members. One of the major variation between shape of the plant body of algae to higher plants. In higher plants, the plant body differentiable into and possesses root, stem, leaves, flowers, seeds, fruits. This complexity is there in plant body of higher plants. Whereas in algae, all these organs, roots, stems, leaves, flowers, fruit, seed, everything is absent. But one greenish mat is present to perform photosynthesis, that's all. It is the meaning for simpler body organization in lower organisms. Now, what are the, note down, these points are very important. Try to note down. The commonest features of all the members of the plant kingdom. One is the eukaryotic nature. Second one, multicellular. Third one, presence of chlorophyll and cellulosic cell walls. And one more point, due to the presence of chlorophyll pigment, there is automatically photosynthetic. So autotrophic mode of nutrition is there. These four features are found in every member of the plant kingdom. In algae, these four features are there, including cell wall, 5 features. In Bryophyta, Pteridophyta, Gymno, Angio, every member of the plant kingdom possesses these 5 as a one commonest or characteristic features, such are eukaryotic cell structure, multicellular nature, presence of chlorophyll and cellulosic cell walls. 2 points are there within the single point. And autotrophic mode of nutrition or photosynthetic nature. Note down what are the 5 commonest characteristic features exhibited by all the members of plant kingdom. Eukaryotes, multicellular, chlorophyll, cellulosic cell walls, and autotrophic nutrition. Okay, completed. These are algal members. In aquatic body or water bodies, at bottom some kind of odd substance like rocks are there. Surface of the rock gradually torn into greenish, slimy area due to the growth of algae. These are bryophyta plants. It is image for pteridophytes and gymnosperms. Flowering plants, angiosperms. Highly advanced plants. Next concept and important, based on presence and absence of seeds. Based on presence or absence, plus NCE presence, minus NCE absence of seeds. It means seed production ability. All the plants in the plant kingdom divided into 2 categories. Non-seeded plants are called non-spermatophytes and seeded plants are spermatophytes. Once again, what is the difference between non-spermatophytes and spermatophytes? Seedless plants are non-spermatophytes. The plants which are able to produce seeds are called spermatophyte group of plants. Sperma, seed, non-seeded plants. Because these are non-flowering. All non-spermatophytes are non-flowering plants. Without flower, there is no scope for formation of fruits in most of the plants. Non-flowering members. Flowering plants are usually spermatophytes. Spermato, seed, plants groups, phytes groups. Examples for the non-spermatophytes. One is algae, second bryophyta, third pteridophytes. Angiosperms are example for non-spermatophytes or spermatophytes. Angiosperms, yes, spermatophytes, because seed production ability is there. What about the gymnosperms also able to produce seeds? That's why Both angio and gymnosperms placed under spermatophytes. Try to remember it. Algae, bryopteros are example for non-spermatophytes. Gymnosperms and angiosperms are example for spermatophytes. One of the specialty of the gymnosperm is the seed production ability is there without flowers. Non-flowering plants. There is no flowers, even though such plants are able to produce seeds. But angiosperms are example for both spermatophytes and flowering plants. Spermatophyte, seed producing ability, and flowering plants. It is a special character of angiosperms. Now try to give one example for non-spermatophytes or flowering plants. Algae, bryo. Fill this blank. Among these four groups under the non-spermatophytes, very primitive algae. We can construct one more statement here. What are the advanced non-spermatophytes? Primitive spermatophytes, non-spermatophytes, algae. Advanced non-spermatophytes, pteridophytes. Non-spermatophytes also called as non-seed producing plants or non-flowering plants. One more technical name is there for non-flowering plants, such are cryptogams. Cryptogams, non-flowering plants. Lack of flowers, such plants are unable to produce seeds. These are bryophyta. Next, spermatophytes. Most of the spermatophytes are flowering, are phanerogams. Opposite to the cryptogam, crypto, non-flowering, phanero, flowering. What are the two examples for spermatophytes? Try to fill these two blanks. Yes, angio and gymno. Gymno and angio are example for phanerogams, flowering plants or spermatophytes. They are also called as the seed-bearing plants. Also called as seed-bearing plants. Seed-bearing, spermato. Such are flowering plants. Try to answer for this question. Which of the following are phanerogams? The following are phanerogams. Answer. In algae, no flowers. Bryophyta, no flower. Pteridophytes, no. Only angiosperms are example for flowering plants. Yes, fourth option, right answer. Good. Angiosperms. Next, one more question. Cryptogams are non-flowering plants. We can make one more statement here. That is, all cryptogams are non-spermatophytes. All cryptogams are non-spermatophytes because in cryptogams there is no flowers. Without flowers, such plants are usually unable to produce seeds. Okay. Next, one more question. Which of these are also called as spermatophytes? Which of these also called as spermatophytes? Spermato, seed producing plants. Answer for this question. Yes, good. Phanerogams. What are example for phanerogams? What are the example for phanerogams or spermatophytes? Examples. Okay, fourth option true, no doubt. But example for what kind of plants placed under phanerogams? Yes, both gymno and angiosperms. Gymno and angiosperms. Next topic, algae. Algae is a cryptogam or phanerogam? Algae is an example for crypto or phanero. Crypto means non-flowering. Non-flowering plants. Next, these are spermato or non-spermato. Spermato or non-spermato. There is no ability to produce seeds, that's why these are non-spermatophytes. And very primitive plants. Plant body is the very simpler. Body of these organs are very simpler. Primitive plants, simplest plants, oldest plants in this planet, algae. All the members of algae are cryptogams and non-spermatophytes. There are no flowers, no seeds. Now the characteristic features of algae. Yes, before going to the detailed account of algae, how to learn wide concept or comparative account of all the members of the plant kingdom. Try to note down 5-column chart. first column, second column, third, fourth and last column. Second row, third row, fourth row, fifth, sixth, seventh, 8 rows. Make it fast. Algae, bryophytes, pteridophytes, gymnosperms, angiosperms. In first column, character or feature. Number 1, embryo is present or absent in the life cycle of this every plant group. One question ready ra. Embryo is found in. Question completed. Options. First option algae, second bryo, third pterido, gymno and angios are 5 options. Embryo present or absent? Except algae, remaining all the members, embryo formation is there. Except algae, remaining all the plant groups in plant kingdom, embryo is present. Lack of embryo in the life cycle, algae is also called as the non-embryophytes. Remaining all are embryophytes. So based on presence and absence of embryo, entire plant kingdom divided into 2 groups. One is the non-embryophyta, remaining all are embryophytes. Example for non-embryophytes, algae. Example for embryophytes, bryo, pterido, gymno, angio. Next, in comparison in second aspect, flowers. Present or absent in algae? Absent. Bryo, absent. Pterido, absent. Gymno, absent. Angio, present. Among these 5 groups, flowers are absent in all the members except angio. Except angiosperms, remaining all the members, flowers are absent. Next, third concept or structure, seed. What are seeded plants? What are spermatophytes? In algae, tell me, algae, seed is present or absent? Absent. Bryo? Yes, absent. Pterido? Yes, in first 3 groups, no seed, that's why algae, bryo, pterido together called non-spermatophyta. What about gymno and angio? Yes, these are able to produce seeds. So gymno and angio together called spermatophytes. Algae, bryo, pteridophytes are non-spermatophytes. One more feature, vascular tissues. Vascular tissues like xylem and phloem together called vascular tissues. Water conducting tissue, xylem, food conducting tissue, phloem. Both are vascular tissues. Based on presence and absence of vascular tissues, entire plant can be divided into 2 groups. Now, first of all, tell me, what plant groups possess vascular tissues? Gayatri, absent in algae, bryophyta, good. What about the pteridophytes? These are the vascular tissues are present or absent in pteridophytes. Okay, no doubt. In gymno and angio, vascular tissues are present, no doubt. But what about pteridophytes? Yes, pteridophytes also, vascular tissues are there. So, first vascular plants in the plant kingdom. One important question, ready? First vascular plants, pteridophytes. First spermatophytes, gymnosperms. Gymnosperms are the first spermatophytes. Plant kingdom short name PK. What is the full form of PK? Plant kingdom. Based on presence and absence of vascular tissues, vascular tissues, all the members of the plant kingdom divided into two groups. Vascular tissue absent in atracheophytes. Atracheophytes. A. Absence of tracheas means vascular tissues. Whereas in other groups, vascular tissues are there, such are called tracheophytes. Another name of vascular plants is the tracheophytes. What are tracheophytes? Vascular plants. Atracheophytes, non-vascular plants. If the both xylem phloem are absent, such are called non-vascular. Technical name atracheophytes. If both are there for conduction of water and food materials, such are called tracheophytes. Example for atracheophytes are non-vascular plants. One is the algae, second one bryophyta. Example for tracheophytes are vascular plants. P. Pteridophyte, G. Gymnosperm, F. are angiosomes. The first vascular plants are first tracheophytes, pteridophytes. Observe this table here. In these four organs, embryo, flower, seeds, and all are absent. That's why you can say algae are very primitive. In bryophytes, only embryo is there, remaining all are absent. Whereas in pteridophytes, embryo is there and vascular tissues are present. Whereas in gymno, embryo, seeds, vascular. Among these four, only flowers absent, remaining all are present. In angio, all are present. Compare the algae with angiosome. In algae, these first four structures absent, whereas in angiosomes, all are present. It is the reason to say angiosomes are advanced plants. Angiosomes are advanced. Algae is very primitive because all these are absent. Based on this table, we can construct several questions. Question number 1, first option embryo, second option flowers, third option seed, fourth option vascular tissues. The following are present in algae. Or simple question, algae possess. No one, all are absent. In bryophyta, only one is correct. In pteridophyta, 1 and 4. In gymno, 1, 3, 4. In angio, all are present. Next, fifth one. What is the dominant phase in life cycle? Here you have to learn some basics about the life cycle of the plant groups. In every plant in the plant kingdom, the life cycle possesses mainly two phases. One is the diploid sporophytic plant body, or diplontic phase is called sporophyte. Haplontic phase is the gametophyte. In every plant life cycle, two phases are there. One is the sporophytic phase, second one is the gametophytic phase. The meaning for the sporophytic phase, spore producing phase is the sporophyte. Likewise, the gamete producing phase is the gametophyte. Spore producing one is the sporophyte, gamete producing one is the gametophyte. In these two phases, generally one is the dominant, means photosynthetic. The phase which is able to produce food material by the performing photosynthesis, that is the dominant and independent. The phase which can't prepare food material by own, depending on other phases, such are non-photosynthetic or dependent phase. Based on these concepts, you can write some points about these five groups in the plant kingdom. In algae, dominant phase or independent phase is gametophyte. Gametophyte is the dominant. Bryophyte also, gametophyte is the dominant. From pteridophyte onwards, sporophyte is dominant. In gymnosome, angiosomes also, sporophyte is dominant. Identify here. Evolution proceeds from independent gametophytes to independent sporophytes. At the beginning of the plant kingdom evolution, gametophytes are dominant. Gradually, such gametophytic nature become as the dependent, and sporophyte become as independent and dominant. One more comparison. Independent and photosynthetic phase. Independent phase. Gametophyte is independent in algae. Bryophyte also, gametophyte is independent. Whereas in pteridophytes, both the phases are independent. Both the sporophytic phase and gametophytes are independent. Whereas in gymnosperms, only sporophyte is independent and dominant. So evolution proceeds from independent gametophytes to independent sporophytes. Independent gametophyte to independent sporophytes. Note down this entire table. Scan all the aspects mentioned in various columns. First, scan all the things are given in algae. In algae, embryo absent, flowers absent, seeds absent, vascular tissues also absent. Dominant phase is gametophyte, independent phase is also gametophyte. Are you able to fill all these things? Try to fill. In algae, I have to mention the 6 points in these 6 blanks. Embryo is present or absent? Embryo is present or absent in algae? Absent. Flowers absent, seeds absent, vascular tissues absent. What is the dominant phase in algae? Gametophyte. Independent phase in algae? Gametophyte. Each and every point is the one question. Yes. Okay, good. Likewise, try to fill all the words are given in regarding bryophytes. From last to first, what is the independent phase and life cycle of the bryophyte? Gameto. Dominant phase also gameto. What about flowers and embryo, seeds and vascular tissues? First, embryo present or absent? Present. Flowers absent. Seeds absent. Vascular tissues absent. Dominant phase gametophyte. Independent phase also gametophyte. Next, coming to pteridophytes. Scan properly to give answers. Try to give answers about the pteridophytes among these 6 which are present, which are absent, which phase is the dominant, which phase is the independent phase. Coming to the first point, embryo present or absent in pteridophytes? Embryo present. Next, flowers absent. Seeds absent. That's why such are non-embryophytes. Vascular tissues present. Hence, pteridophytes are the first tracheophytes. What is the dominant phase in the life cycle of pteridophytes? Sporophyte. What are independent phase? Yes, good. Independent phase in pteridophytes. Is a special feature. Both sporophyte, gametophytic are both are independent. Both are able to prepare their own food material. Okay, good. Next, about the gymnosperms. First of all, you have to scan all these concepts given under the column of gymnosperms. Tell me, what about embryo in gymno? What about the embryo in gymno? Present. Flowers present. Seed present. Flowers absent. Seeds present. What about vascular tissues? Yes, vascular tissues also present. What is the dominant phase in the life cycle of gymno? The sporophyte. What is the independent phase? Means photosynthetical and food preparing phase or autotrophic phase. Sporophyte. Last plant group and highly advanced plants at the present day in this planet. Angiosperms, nothing but flowering plants. Try to fill all the blanks regarding angiosperms. Yes, all are present and independent phase is sporophyte. Embryo present, flower present, seed present, vascular tissues all are present. It is the reason to say these are very advanced plants in the plant kingdom. Sporophyte is both dominant phase and independent phase. In life cycle, sporophyte is the dominant as well as independent. Okay, it is a comparative account. we can make several questions by using the data given in this table. That's why it is very, very important. You must note down this table. Okay. Next chapter, algae. I will explain detailed account of algae next class. Okay, now bye. Bye.
Hello, good morning students. Very good morning to all of you students. It might be your heart, it might be your lungs, it might be your kidneys, or it might be your stomach and intestine. It might be your liver, it might be your pancreas, all body organs, all organs of your body. As you know it, no organ can function independently of each other. Each and every organ has to communicate with other organ, then only they can live comfortably. So this communication between two organs. So what do you mean by communication? Communication is so simple. Who will act first? Who will function first? Lungs will function first, followed by heart, then by blood. So there might be a sequence of functioning of all these organs, right? This communicated sequence of functioning of all organs, orderly functioning of all these body organs, what do we call this? Coordination. Every organ will communicate with each other and will decide at what time they may act. So that communication was referred as coordination. And all these organs does have a boss. There is a boss. There is a head of this organ system. There is a head of your body organ systems, head for every organ also. Most important part of your body, most important organ of your body, without which all these organs cannot function properly. And this boss organ rules over every organ. It was a boss, dictator. What was that? Brain. More than 95% of your body coordination activities will be controlled by brain. If any organ was not listening to brain, not responding to neurons, still there is a way to communicate with such organs also. As I also told you earlier, your body consists of two types of communication, wired and wireless. Brain is providing you with wired communication, whereas wireless communication is with the help of endocrine glands which secrete hormones. Both are there. There is coordination carried out by brain, we refer that as neural coordination, and coordination done by hormones, we say that as chemical coordination, right? So there are neural coordination as well as chemical coordination also. Today we will discuss fundamental aspects about neural coordination. How does brain coordinate with other organs? Before we learn about coordination with other organs, remember this. First we should know about morphological features of brain tissue. We'll cut it and we'll also see anatomical aspects of brain also. So brain associated with other cells, tissues, blood supply and all accessory things will comprise your nervous system. Okay. In this nervous system, the part of nervous system which is actually protected by your bones. I mean to say, there was a part of nervous system inside your head region as well as a part of nervous system protected by your vertebral column also. So if nervous system component was protected by bony endoskeleton like head and vertebral column, the part of nervous system which was confined to your axial skeleton, we refer that as central nervous system. The part of nervous system which was confined to your axial skeleton, the part of nervous system which was actually protected by your skull and vertebral column, that was central nervous system. It includes only two organs. What are those? Brain, and then inside your spine looks like a thin cord, therefore spinal cord. Same time, all those neurons, all those nerves which come out of them, which occupy lateral parts of your body, these neurons will help in bringing signals to a CNS and also sending responses from CNS. All those neurons which help you to respond, react and receive stimulus, we refer the part of nervous system which is in your lateral parts of your body, which is confined to appendicular part of your body, appendicular skeleton, that was referred as peripheral nervous system. Nerves or neurons which send impulses to CNS and which receive impulses from CNS. These neurons or nerves are referred as peripheral nervous system. Now, if they send and receive information from voluntary organs, neurons associated with voluntary organs was referred as somatic nervous system. So those neurons, nerves which interact with voluntary organs, we refer that as somatic nervous system. Okay, whereas there are many nerves and neurons which associate with involuntary organs or involuntary muscles. All those neurons or nerves which interact with involuntary organs and involuntary muscles, we may refer that as automatic or autonomous nervous system. We can call it as automatic or autonomous nervous system. These automatic neurons may excite an organ or may inhibit functioning of an organ. Guys, automatic or autonomous nervous system, it has two wings depending on chemicals. Some of these autonomic nerves, they can excite an organ. Excitement means doing function which is more than normal. Whereas there are some neurons in autonomous nervous system which actually can bring down that excited organ to normal state, and sometimes may ask this normal organ also to slow down your functions, which means autonomous nervous system may excite an organ or inhibit an organ. The part of autonomous nervous system which excites your organs is called as sympathetic nervous system, whereas that component of autonomous nervous system which inhibits your activities is referred as parasympathetic nervous system. Done. So autonomous nervous system also has two components: sympathetic for excitement, parasympathetic for inhibition. Done. So sympathetic for excitement, parasympathetic for inhibition. Both are components of autonomous nervous system. Autonomous nervous system is a component of peripheral nervous system, and peripheral nervous system is actually a subcomponent of main nervous system. And guys, nervous system, yes, it was composed of two types of cells and matrix. The main kind of cells which perform conduction and relay of impulses. The main cells which are concerned with receiving stimulus and sending responses, those conducting wires were referred as neurons or nerve cells. Whereas these neurons must be fed. There must be some kind of cells which must give food to neurons, which must provide matrix for neurons, which will clean ammonia from neurons, and same time these cells will also protect neurons from some foreign invaders like bacteria, virus, protozoan, etc. There are some cells found adjacent to neurons which are known to support, nurture, protect neurons. These cells which are acting like supporting cells for neurons, these were referred as glial cells. And in some textbooks, we also mention that as neuroglia. And for your surprise, most of our nervous system is not neurons. More than 60%, between 60 to 70% of your nervous system was composed of glial cells, and almost 30 to 40% of our nervous system is actually made up of neurons. So nerve cells. Okay. So neurons comprise 30-40% maximum, whereas glial cells, glia means glue, gum. Neuroglia, they comprise mostly 60 to 70% also. They may have different types also, not now. We have time for this. Okay. And one more thing. In PNS, if you speak again, this is CNS with brain and spinal cord, right? PNS like this. CNS and PNS. Okay. Guys, please do remember one thing. Those neurons see this carefully. There are neurons or nerves. Neuron is a single cell. Nerve is nothing but linear arrangement of many neurons like this. This is a neuron. This is a single neuron. Okay. This arrangement can be referred as a nerve. Neuron and nerve. Now the thing was, neurons or nerves, they pass on stimulus from sense organs to CNS. See this arrow. Those nerves or neurons which send stimulus to your brain or spinal cord or CNS. Neurons which pass on stimulus, we refer them as sensory nerves or afferent nerves, afferent neurons. Okay, they send stimulus from sense organs to CNS. And there are some neurons which they carry response, reaction from brain or spinal cord to organs. These are muscles. Usually we refer them as motor organs. In some textbooks they also refer that as effector organ because it will show the effect, response, reaction to a stimulus. So those neurons and nerves which carry impulse from CNS to organs, we refer them as motor neurons or motor nerves or efferent neurons, efferent nerves. They carry responses, reaction. Okay, receiving sense organ, sending motor organ, receiving sensory neuron, sending motor neuron, receiving afferent nerves, sending efferent nerves. See this carefully. Done like this. So what was the role of CNS now? CNS receives stimulus, analyze it, memorize it, think about it, and then creates a response which will nullify this stimulus. Each action has equal and opposite reaction. Each stimulus will be responsible for a response. One efferent neuron may definitely activate the other efferent neuron also, right? So the main location where stimulus gets analyzed, memorized, thought, and this thought process will be shown outside with the help of efferent neurons like this, afferent, efferent. And this conduction of impulses or sending of responses was mainly done by neurons, as we discussed earlier. A neuron may have many shapes or many categories depending on your classification method. Like this. This is a neuron. This is also a neuron. Even this was also a neuron. Done. Guys, this elongated portion of a neuron was known as axon, right? Axon. These end parts of neuron are nerve terminals. Okay. nerve terminals. And the place where is a nucleus, this part, it was referred as cyton or cell body. And cyton or cell body often consists of many 80s ribosomes attached to rough endoplasmic reticulum. You can see many 80s ribosomes attached to rough endoplasmic reticulum. They may look like thick, dark granules inside cell body like this. What do you call these granules, which are actually ribosomes attached to endoplasmic reticulum? These were referred as Nissel's granules or Nissel's bodies. Okay, Nissel's granules or Nissel's bodies, done. Now, this is a neuron with one axon and no dendrites. This is a neuron with one dendrite and one axon. This is a neuron with many dendrites and one axon. Done. So the neuron with one dendrite and one axon, this was referred as unipolar neuron. No dendrites, only axon. This was unipolar neuron found in embryonic stages of our brains, embryonic neurons, we call them as. Whereas if a neuron has one dendrite, one axon, that was bipolar neurons found inside retina, usually bipolar neurons. If they have many dendrites and single axon, this was multipolar neuron. Okay, so unipolar, bipolar, multipolar neurons. It was based on number of dendrites. Do they have dendrites or they do not have dendrites? If they have dendrites, how many do they have? One dendrite or many dendrites? No dendrites, only axon, unipolar. One dendrite, one axon, bipolar. Many dendrites, one axon, multipolar, like this. This is one kind of classification of neurons. And one more thing was, sometimes it might be unipolar, bipolar or multipolar, that was another issue. But if neurons were actually covered by myelin sheath made by Schwann cells or oligodendrocytes, like this. Sometimes Schwann cells or oligodendrocytes, they may form a fatty rich layer around axon. This fatty rich layer was referred as myelin. As it looks like a shield, we refer that as myelin sheath. Neurons with myelin sheath were myelinated neurons. Their conduction is very fast. There are some neurons which may befriend Schwann cells, but these Schwann cells did not form myelin sheath. They may have Schwann cells here, but these Schwann cells did not help in formation of myelin sheath. If this was the case, these neurons were referred as unmyelinated neurons. Guys, both these cells are having French Schwann cells, but in this condition, Schwann cell has formed myelin sheath, but here Schwann cell did not form myelin sheath. Therefore, myelinated neurons, unmyelinated neurons. So conduction speed of myelinated neurons is almost 10 to 20 times better than unmyelinated neurons. Some children were born with a genetic condition where their myelin sheath is not properly formed. Yes, their brain usually consists of unmyelinated neurons. They will become mentally retarded with loss of physical psychomotor skills. And if a person is very unlucky, his own immune system may kill his myelin sheath, like which has happened in Stephen Hawking, wheelchair scientist. You guys know about him? Stephen Hawking, wheelchair scientist who operated with single finger, who gave information on black holes. You know that person? Stephen Hawking. So even Stephen Hawking, he has a very rare condition that his own immune system killed his myelin sheath. Therefore, he has lost his communication, lost his conduction. That happens. If you're unlucky, that may happen. So having proper myelin sheath is very much good for brain health and physical health also. This is cell. Coming to the brain, we'll discuss about CNS first, then we can go on to PNS. So CNS comprises of two organs only, brain and spinal cord. Brain, cerebro in German, encephalo, Latin, and inside cephalo, head. So cerebro or brain or encephalo, all of these terms means same thing, brain. Your brain was made up of 80% fat tissue, 20% carbs and proteins. Brain cells, neurons, were considered as one of the longest cells of our body. Longest neurons are found in giraffe, neck, as well as in ganglia of gigantic squids, Architeuthis. Once you Google Architeuthis, giant squid, it also has got one of the longest neurons in animal kingdom. Even 10 to 20 foot long neuron is also found in neck of giraffes. That was possible. So brain as such is a part of CNS, and brain is always protected by your skull. But between your cranial bones and soft brain tissue, there is one more protection. Just like how heart has pericardium, lungs possess pleura, kidneys have peritoneum, our body has skin. Similarly, brain does possess protective layers around them. The protective layers around brain were referred as meninges. So assume this is a brain with folds. There were in humans 3 meninges. The softest innermost meninge, which was actually touching brain also, this one. There's a very soft meninge which is in contact with brain actually. This innermost meninge was referred as pia mater. Pia mater. Whereas there was a meninge which is very thick and found attached or touching cranial bones, your skull. There is a meninge which is very thick, very hard, very tough, almost a bony texture. This hardest meninge, which is outermost and which is actually touching bones also, This outermost tough meninge was referred as dura mater. And between dura mater and pia mater, there was a middle meninge which looks like a spider's web because of its vascularized nature. The middle meninge was referred as arachnoid membrane. Arachnoid. So innermost pia mater, outermost dura mater, middle arachnoid membrane. Okay. Pia mater innermost, middle arachnoid, and outermost dura mater. Okay. Pia mater touching brain, dura mater touching skull bones, and arachnoid it is between pia mater and dura mater. And if you see, brain could be studied in three components, three parts, guys. Human brain is very complex organ. It may look pinkish gray outside. If you cut inside, it will look whitish inside. Surface of brain looks grayish color, therefore gray matter. In interior of brain looks whitish yellow because of myelin sheath. We refer that as white matter. So gray matter outside, white matter inside. And brain has prominent folds. Folds of the brain increase their surface area. So elevation and depression both were there. Elevations are known as gyrus, plural gyri. Depressions are called as sulcus, plural sulci. So elevations gyri, depression sulcus. Elevation gyri, depression sulcus. So gyri and sulcus will increase surface area, therefore brain can accommodate more and more neurons. Done. We learn fundamentals only here, not detailed things, fundamentals. Okay. Now, for our convenience, we may learn brain in three components. So, functional is not physical exactly, functional speaking. Human brain could be functionally split into three parts: forebrain, midbrain, hindbrain. Forebrain, largest part, midbrain, smallest part, and dorsal side it was hindbrain. Like this. Forebrain was here, midbrain, and then hindbrain. So guys, forebrain, I'm giving you that in red color. This is forebrain. Midbrain is below forebrain. I'm showing that in greenish color. Done. And yellowish, I'm showing that it is hindbrain. Hindbrain consists of three components: pons varoli, medulla oblongata. This is pons, medulla, and ventral side. This is cerebellum. So forebrain, midbrain, hindbrain. Forebrain is here. Hindbrain. Hind means back, dorsal. Forebrain, hindbrain. Between forebrain and hindbrain, you can see midbrain like this. Done. That is from side view. This side view. But if you see from front, this view, you can only see forebrain, not midbrain, not hindbrain. From front part, from ventral side, you can see only forebrain like this. And you can see forebrain has been split into two parts actually. Left hemisphere, right hemisphere. Forebrain has cerebral cortex and diencephalon. Forebrain has cortex. So cortex or cerebrum. Cerebrum has two parts, left part, right part. Left hemisphere, right hemisphere. And both these hemispheres are touching each other with the help of tuft of myelinated nerve fibers called as corpus callosum. Okay, so guys, stick to fundamental things. Brain can be split into three components: forebrain, midbrain, hindbrain. Forebrain is visible clearly from the ventral side. Hindbrain is visible clearly from dorsal side. The hidden part was midbrain, which was between forebrain and hindbrain. Okay, so forebrain is about thought process, thinking process, analysis. Midbrain is about audio, video, visual inputs. And hindbrain is mainly about controlling your reflex actions, controlling digestion, controlling heartbeat, controlling respiration, and controlling involuntary activities. Okay, we'll continue next class. Take rest, stay indoors, stay hydrated. Thank you. We'll meet again.